Okay, so folks, hi, this is Robin. Once again, we are back with the Humans of Testing online webinar. This is chapter 5, episode 5, and you see the two nice gentlemen in the picture. One is me, obviously, but then I'm super excited about Keir. Love his bow tie in this profile picture. Today's topic will be one which is close to both of our hearts, testing in the age of agents. This is something which started this whole mission at TestZeus, and there's something Kier is also very passionate about. We'll see how you can go from disciplined code to human guided automation. So let's get going. Onto the first slide, please. Thank you. Quick introductions for the folks who don't know us. My name is Robin. I'm the co-founder and CEO at TestZeus. I'm also an open source contributor, international speaker at events such as Dreamforce and TDX, and author of the Ultimate Selenium WebDriver for Test Automation book. At TestZeus, we build AI agents for Salesforce testing and automation, amongst other enterprise platforms. We'll have a link down at the show notes or at the end of the presentation. Feel free to give it a shot. But on to the next slide. So we have Keir today, who's our guest of honor. Keir is an experienced technology veteran of the IT industry, certified technical architect, Salesforce MVP Hall of Fame, and speaker at Dreamforce, World Tour, and Salesforce community events. Keir is also the proud owner of a golden hoodie and two fur babies, which I have been told very recently. If you go to Keir's LinkedIn profile, you'll find one of their older ones. So that is how we got connected. And we're super duper excited to have Keir as one of our guests today. On to Keir and on to the presentation, please.
Thank you very much, Robin. It's great to be here. Thanks for the invite. So yes, this is what I'm going to be talking about today, testing in the age of agents, from disciplined code to human-guided automation. So let's get straight to it. So the first thing I wanted to talk about actually isn't so much the agents, it's about the importance of testing. I was listening to a podcast a couple of days ago when I was walking my dogs in the morning. And it wasn't about Salesforce development, it was just about software development in general and the involvement of AI. And one of the guests said, I'm really pleased that AI is going to write the test for me because I don't see tests as a creative activity. It's just something really boring I have to do. So I'm happy to let the agents take it on. And I thought it's a real shame that we're seeing that attitude, because I've always seen tests equally as creative as writing the code itself. I think, we developers should be taking pride in producing a robust set of unit tests when we finish development. We should be looking for efficiency and elegance, just like we do in our regular code. So, yeah, I'm going to talk a bit about that and why I'm slightly disappointed with that attitude. So first thing I wanted to talk about was the current reality of Salesforce unit testing. So I've been involved in the Salesforce ecosystem for coming up for over 17 years now, probably 17 and a half years, something like that. And I think one constant has been that we've never, and with notable exceptions, so I'm pasting with very broad brushstrokes here. So some people do a really good job, some organizations do a really good job, but a lot of the time the tests we produce aren't great, and in my experience they've never been great. And some of that is because we see it as a tax, we see it as a problem, it's something we have to do to get things into production. But also I think it's because we don't really approach it very well. What I see a lot of the time is gut feel. It's driven by intuition. What do I think might break? That's often how tests get written, rather than what's important to test. If something which matters not at all breaks, that's not as bad as something which handles financial transactions. So why am I just doing it on gut feel? And when we get gut feel and intuition involved, typically what that means is we think this bit was really hard to write, therefore I need to test it really well because that was quite complicated, regardless of how important it is and how useful it is. And it also means that we think, well, that bit was really easy, so I don't need to worry too much about that. I can easily I can easily test that. I know it all works because I had no problems building it. And in my experience, when I do that, my hard to write stuff is rock solid, and the stuff that I thought was easy does have bugs. It has off by ones, it has various issues with it. So I think The problem here is this approach is very much reflective of how well we understand the code that we've written, rather than how well or how much we're thinking about the business requirements. It's because we've got a good understanding of the code. This bit's hard, this bit's easy, this bit's nice. I'm going to do loads of tests for that because I really enjoyed writing it. The problem is it doesn't scale. So the more complex the code base becomes, the less likely it is that important scenarios will occur to us. So we'll end up with a very wide-ranging test suite, but often not great. So we'll often have 2 to 3 obvious test cases. So, typically you might get one happy path, or this could be null. I better put in a check for that. And maybe I'll do a negative test. Maybe I'll pass -1 when I'm expecting a positive. And we do that. And then we run through a show and tell with the customer. And the customer's like, yeah, that's great. That all seems to work. And then it hits production data, with very different record shapes, lots of different data, and it fails. And at that point in time, that's when we start doing going through triaging things and putting in the tests to confirm our fixes work that we should have had in the first place. The bugbear I've always had, the constant personal bugbear for me, is the 75% coverage means my testing is done. And that could not be further from the truth. I think an awful lot of us realize this. 75% coverage is what you have to do to get something into production. And the reason for that is Salesforce needed to have a gate to stop things just being chucked over the fence into production. Coverage is something they can measure. They can't really measure many other things around testing. That's one of the difficulties. And they had to pick a number, and 75% felt like a fairly high bar. But it's not, some industry metric that means if you've got 75% coverage, you can be sure you've got a quality code base. Coverage does not equal quality. It only tells us which lines we were able to go through in a test environment without the code failing. Simple as that. High coverage, you can hit that really easily without any meaningful tests, without any asserts. I always think of code coverage that in many ways it's a negative metric. What it's doing, if I've got a low code coverage, that tells me that my tests aren't hitting a lot of my code. So that's my problem. It doesn't tell me that 75% is good. It tells me that 25% is totally untested. So maybe harboring problems, but it doesn't mean that 75% is fine. It just means I at least have looked at that.
Yeah.
And the final point of high coverage, but how confident are we? So if we reach 100% coverage, we know that none of our code is untested in quote marks, but we don't know how much of it is adequately tested. So this is one of those things where I would always say to people, like, do you feel you've got enough tests there? And it'd be like, oh yeah, I've got 80% test coverage. Like, so you're okay if I go in and just refactor how all of that works? I just rewrite the whole thing as long as I adhere to the contract. You're happy that your tests will pick up any issues that I might introduce. Rarely did I get the answer, yes, that's fine, go ahead.
I'll actually pause you, Keir, and
Sure.
reminds me of this anecdote. I was looking at a code base of a Salesforce implementation. You might laugh at this, you might get angry. I don't know. We'll see. Maybe so one of the developers had just written, in the tests that at the rate test, and if true, then print true, something like that. So they had a test,
Yeah.
and when I looked at it, and I was like, why did you do this? Like, what's happening here? Then they were like,
Yep.
Robin, this has to be deployed tomorrow. If I don't do this, are you happy to take the release on Monday? I'm like, okay, this is fine. Yeah.
Yeah, and then I think a few of us will have seen the code introduced to get the test coverage up. So 1,000 lines of I equals I plus 1, then a test that executes that method, and then suddenly we've got a decent amount of test coverage. We've no idea whether that code is going to work in any way, shape, or form, but we've managed to get it through. And that's the problem, I think, is that a lot of the times tests are seen as this tax. They're not seen as part of the software development. They're not seen as something that you should be focused on, you should be doing.
Yeah, I think this is like a t-shirt quote. I love this, what you said. I might get like a t-shirt maybe for the both of us, which says testing is not a tax.
Absolutely. But it is seen as that. It's seen as something I have to do rather than something I want to do. Which I disagree with. I think, I mean, personally, I don't practice test-driven development. I don't think I need to write all my tests before I write any code, but I certainly write them in conjunction with each other. And I think that's absolutely right. And I don't want my code to break under any circumstances. So I will, where possible, I will test it to destruction.
Yeah, love it. Okay.
Okay. So yeah, gut feel. gut feel isn't a strategy.
Yeah.
You miss edge cases because your intuition can't allow you to think about things like records with fields that are valid, but it's also empty. Empty related lists or very large related lists, boundary values. As an org grows, a production, and a lot of orgs are very mature now. A lot of orgs are like, 15 to 20 years old. They've got huge amounts of data. And they've got varying shapes of data, some of which they probably wouldn't be able to enter now because they've got various rules in place, but that data hasn't been touched in years. But your code has to handle that. So the combinations of records that exhibit one or more of these characteristics, they grow exponentially, really. But our intuition remains the same, and it stops being good enough. And the next point I think is really key. Testing what we wrote, not what we meant, and that's. Well, if you see testing as attacks, you do tend to just let me test this implementation. I've got this condition here, so let me test that condition. We're not testing what this is supposed to do, what this piece of code is supposed to do. We're testing how we implemented it because we must have implemented it correctly. And what that means, if you've got bugs, then if you write tests like that, your tests will erroneously confirm that everything is fine, and the bug will then make its way into production. As I mentioned before, coverage isn't confidence. You can get very high coverage, no assertions, and have very little confidence. To get confidence, you need to be testing decisions, you need to be testing boundaries, you need to be testing constraints, all against the business requirements, not how you structured that code. And I think also something that's missed when we talk about intuition and gut feel is it's not a repeatable mechanism for creating good tests. We're lacking developer discipline at that point in time, because it means that different developers could well produce different test suites for exactly the same Apex class. So the test quality then becomes something that depends on who wrote those tests, and that's a really bad thing. We don't like code quality where I've got developer A who probably won't do a very good job and developer B who do a really good job. We don't tend to accept that. We try and get everyone to a decent level. Whereas if we're writing tests on gut feel, we are effectively allowing that to be the case, that we'll just, if it's poor quality, it's poor quality. They're not testing against the risks, and then there's no methodology being followed. That's probably the best way of putting it.
Love it.
So what should we do? What we should be doing, and there's a reason we should be doing this, not just for how we work now, but for how we're going to have to work in the future. But we should be using proven test techniques. And this changes things from what can I think of to test to what cases does this technique cover. It makes test designs repeatable across individual developers and teams. It gives you consistency, and it gives you better tests which are focused on decisions and things like failure modes. So some examples of some proven test techniques, and I wonder how many people listening have ever used any of these. So boundary values. So most defects we find live on the edges. We're off by one, we're doing greater than rather than greater than or equals, something like that, minimum, maximum values when we're transitioning from valid to invalid. And boundary value testing traps this kind of thing. So if we take an example of a piece of code that says a discount on an order must be between 0 and 30%. If we're going with gut feel, we might do 15. Is that valid? Yes. 45. Is that invalid? Yes. Good. We're all done. With boundary testing, you'd go to the boundaries. So you'd say -1, that should be invalid. 0 should be valid. 30 should be valid. 31 should be invalid. That means if we've got something which says it must be greater than or equal to 0, less than or equal to 30, and somebody then inadvertently removes one of those equals, we trap it. We've got tests that are testing exactly that transition. If we're doing gut feel, we haven't got that. The 0-1 many is probably one of my favorite ones. And again, I think with gut feel, we'd probably do a variant of this, but if you actually sit down and think about it and design it, you will hit all of the things, all of the aspects of it. So 0-1 many, effectively, when you're testing code that involves records, you would test it with 0 records, with 1 record, and with many records. But that's not just necessarily like you're passing a list of opportunities into a method. It's also what related records does that have? Does it have opportunity products? Right, let's test opportunity products with 0, with 1, with many, all of those kind of things. Once you start following the object graph about what is important, you'd be surprised how quickly that starts to pay dividends. And it's really good at catching bugs like DML or SOCL in for loops. If you've got custom roll-up code, it's really good at catching that. And probably the main one it catches is there will always be one. There's so much code out there that just assumes one will come back. And if it doesn't, then yeah. And if you're testing with many records, you're also got a good chance your code is bulkified, a particular issue for us Salesforce developers. An empty input is another good one. An empty is different to null. So we'll often null check, we won't often empty check. And often times as well, empty is a valid value. So this kind of thing is, again, great for identifying hidden assumptions about the size of strings, about the sizes of collections, or when fields are assumed that they always have to be present, but actually in production they're not present because that isn't the case. So those proven test techniques, if you sit down, go through them all and design tests to using these techniques, you will end up with a robust set of tests in design. But you're not necessarily going to have the opportunity to build all of those tests because there isn't an unlimited budget. Much as we'd all like to test exhaustively, there is never an infinite test budget, even if you're doing product development. So you have to have trade-offs. If you're writing tests based on gut feel, generally speaking, you'll stop when you hit 75%, regardless of what you might have done. But if you've designed your tests, you can then prioritize those. You can then look through those tests and say, okay, which ones do we need to prioritize based on the risk to the business if there is a problem with this code in production? And not just in terms of bugs, but also how likely is this code to need to change? Is this business requirement something which we know is going to change and we need to be ready for that? So we need to have some decent tests so that when we do change things, we only the things that we expect to change have changed. Might be around cyclomatic complexity, that it's a particularly decision-driven piece of code, or it might be something to do with compliance or security sensitivity. It may be that there are certain pieces of data that we shouldn't be able to see, and we may be breaching some kind of GDPR rule if we're allowing people to see that. So we probably want to test that we aren't letting that go, because that could end up costing us a lot of money.
Yeah, I think like I'm looking at the chat as well, and Beach is saying one of the struggles with testing was to also look at the governor limits. So I think that is another angle that people should touch upon.
Yeah, absolutely. I mean, yeah, governance, and you do have uncatchable exceptions in Salesforce. But the reason you typically have those uncatchable exceptions is because you brought too much work into the transaction. So that's when you then start looking at, well, how are we actually, that's when you're doing your 0, 1, many type of testing. It's not just about allowing someone to maybe choose 200 records on the screen. It's then if you need to go and do a whole bunch of processing on all of the related records for those 200 records, 0, 1, many testing will allow you to see how well your code is going to scale. And that is something that is worth looking at as well. You don't necessarily have to do thousands of records to determine how it will scale, but what you do need to do is basically do some increments. So do 1 record, do 10 records, do 100 records. If you're seeing exponential growth, that probably means it's not going to go much further. Whereas if you're seeing a nice flat line, that means you've written it very well and it's going to scale. So yeah, it's absolutely a challenge, and it's definitely something which I think should be in testing. But I think the thing to avoid with testing around governor limits is just picking some arbitrary value and an arbitrary bunch of data and saying if this limit goes over 60%, then that means it's an error, because it's not an error. That isn't a failing test. What that is a warning, but that's the only way you've got of surfacing the warning to the developers. So yeah, I would be looking to do that through something else, probably through some kind of test automation rather than through unit tests which you have to deploy to production, etc. I think it's always worth thinking about, does it belong in unit tests, or is actually this something which sits better in another application, another system? Got it. Okay, thank you. Okay, so the next part I wanted to talk about, so obviously we're all convinced now that doing testing properly is a good thing, so we can move on. What's different about testing agents? Because I think for those of us who've spent, more than a decade, or in my case, like 3 or 4 decades, writing unit tests for regular automation, agents are a bit different to that. So we need to apply things differently. So when we're testing Apex is deterministic. So a key aspect of determinism is predictability. So there's no randomness involved. If we don't change anything, the results will also not change. The same input will give us the same output, give us the same starting point, same input. A deterministic algorithm will produce the same output. And if you haven't changed the code, it'll pass through exactly the same states. So that's great. We get isolated, repeatable, predictable tests. This is what you want from unit tests. They're isolated from the data present in the sandbox or production system. You want that. We're in total control of the starting state, and we know we're not going to impact any of that. Repeatable tests, very important when you're doing continuous integration, when you've got a regular release cadence. You want to be able to run them over and over and over again. Also, if a test errors when you run it, next time you run it, it will also error. You don't want things that error occasionally because you'd never be able to track them down. And once we fix a test, we can be sure that it will remain fixed unless something else changes. So when we're testing deterministic code, it's a very straightforward pattern for us. We arrange, we do the setup, we act, we execute some code, and then we assert. And we assert, does the state of the system now match what we're expecting having run that code given that starting point? We're all very familiar with that, hopefully. Agents are probabilistic, very different. They're not deterministic. So we've got to rethink our approach to them because things aren't repeatable. They don't do the same thing every single time. So one of the reasons we like agents is they have a spark of creativity. If we ask them to generate 5 emails to 5 different customers, probably be really annoyed if it came up with 5 identical emails. We want it to do things differently. So outputs vary. 2 responses to exactly the same request, maybe seconds apart. The wording changes, the tone shifts, the structure switches. Sometimes you get bullets, sometimes you get paragraphs. You never quite know. But automated testing is generally looking for predictable output. So that gives us a bit of a challenge. There are many correct answers. So for most agent test cases, there isn't a single right answer. You generally speaking wouldn't use it for something simple automation, add these few numbers from these records together. You're doing more complicated things. So there's usually a collection of acceptable answers that satisfy those business requirements. So we're going from, is this the correct response, to, does this look like a reasonable response? And that's quite a challenge to do in code or in automation. Results change over time. The Apex runtime rarely changes, and when it does, it's normally around API version. Agent behavior changes when you haven't done anything at all. It may not even have been updated itself, but the model may get updated. Retrieval behavior, you may be retrieving some more records than you were last time, and that changes things. So it means you need to be running regression testing almost on a cadence rather than when you're doing a deployment. We've moved from that. We run all the tests when we deploy to production, and then we can, as long as we don't change anything, we can be relatively confident. This is something where we really need to run those tests over and over again. And we need to match on ranges and patterns rather than exact values. So we can't reliably assert the contents of responses anymore. So now we're looking for characteristics of the responses. The responses we're expecting are there. Forbidden aspects aren't there. The values fall within acceptable ranges. The structure of the response matches a pattern. We're testing intent. We're not testing exact text, and that can be really quite tricky to do. So if we look at Agentforce testing, this has moved very much into observability. So we're not solely concerned with the output. That's obviously important. But we also look at how the agent decided to arrive at the output, because one of the things we're reliant on is the Atlas reasoning engine. Why did it decide on those steps? So in order to achieve this, we have to look at what the agent did. What topics did it choose? What actions did it choose? Do they match those that we expected it to pick based on the request and how we've configured the agent? This is where we do get a small amount of deterministic signal within a probabilistic test. And it's very different to how we test Apex, because we typically wouldn't look at what it did, because that ties us to the implementation. We're concerned about outcomes. We should be able to refactor the implementation. With Agentforce, we're kind of turning that on its head. Another thing that's kind of really different for us, for those of us coming from Apex, is the correct outcome arrived at through an incorrect route is a failure. Just because it came up with the right answer, if it didn't come up with the right answer for the right reasons, then that's a fail. And that might seem really picky, but by using topics or actions that it shouldn't have chosen, that could have bypassed guardrails, it could have broken compliance, it could have had access to data that it shouldn't have access to. So that's a fail. And again, that's a really unusual way of thinking. Something else, a challenge we have with Agentforce is there's no test framework, so changes persist after tests complete. There's no rollback. If the agent creates or updates records, those changes persist in the Salesforce database. Obviously, only testing scratch orgs, sandboxes, and you need a strategy to reset the org to its known state before you run any tests. You almost want disposable orgs like scratch orgs. And then something else that we don't have to worry about in Apex is the fact that test runs cost money. In Apex, they don't. We can run them every day. We can run our entire test suite. It costs us nothing apart from an internet connection. Whereas by testing Agentforce, we are making requests to large language models. We are consuming tokens. Large regression suites could result in a significant cost. Regular continuous integration or regression cadence could result in a significant cost. However, we aren't in direct control of the model either. So we do need to be doing some regular testing and trading off how much we're wishing to spend on that. So effectively, rather than doing release validation, we're doing continuous validation, and that is costing us real money. So that's some things we have to be concerned about when we're testing Agentforce.
Yeah, I think just one more item, Keir. So, representing the audience and people listening to this.
Sure.
See, interestingly, when I started my career as a QA, and as you said, boundary value analysis or 0-1 many is an approach we can take for deterministic systems. Very interestingly, in testing agents and let's say Agentforce testing, there could be infinite scenarios.
Absolutely.
But neither do we have infinite time, nor does anybody have infinite money for testing. People have very finite budgets for testing. So what would you recommend people when they are scoping out their tests for Agentforce testing or testing out agents?
So the main thing I'd recommend is talking to the users and finding out how they're going to use it, what kind of things they're actually going to do with it, because that's what you need to be testing. That's what's so I think this is one where we have to work more closely with the users to understand how they work, what data they're going to want to pull in, what kind of questions they're going to ask it to do. You can really get a good understanding there, and I think when you know that, you can be very targeted about that testing. So if I don't know, let's say a sales user says, well, personally, the way I plan to use this is I'm going to look for neglected accounts. So that's something, then you can do a bunch of tests around that. Whereas if it's just a sales agent, there could be a huge amount of possibilities. So yeah, I would say identify how people think they're going to use it, and also keep that line of communication open, review with them regularly, because they're likely to then think they're going to do some different things with them and try and get ahead of that. But yeah, I think it is a challenge. Agentforce can synthesize some data for you, but obviously, unless you've got very deep pockets, that could get quite expensive as well.
Yeah, I love the idea that to test agents, you should actually get closer to the human users.
Absolutely,
that will give you the real insights on what you need to focus on. Thank you for that insight.
Absolutely. And it brings us to the final point, which is agents doing the testing. The agents are writing the tests. So what kind of things do we need to think about there? So it turns out if you just ask agents to write tests based on code, you say, I've got this method, write the test for me, and that's all you give it. They tend to behave very similarly to us with our gut feel approach. They will infer what it should do from the code. That's all it's got. That's the only reliable source that it has. So it has to infer rules, thresholds, constraints, boundaries by analyzing that implementation. And what it's learning is how it currently behaves, not how you intended it to behave, or why it behaves like that. So you end up in exactly the same situation with the tests confirming what the code does. They validate existing branches and outcomes. They assume it's, I could have something where my method is validate, as I was saying before, validate discount. It should be between 0 and 30. That's what the requirement is. And I've done it between 10 and 20. I guarantee you an agent will write a test to prove it's between 10 and 20. and they'll be more than happy with that because it doesn't know what I was trying to do. Yeah. So if the code is wrong, the test will be wrong. Defects in the implementation are treated as correct code by the agent. Again, faithfully encoded in the tests, expected behavior, confirm the code is working as expected. So rather than catching mistakes, what your test suite is doing is reinforcing them. And there's a name for all this, which is the mirror test problem. So the mirror test means that the test suite becomes a reflection of the implementation. Instead of challenging the code, which is what it should do, it agrees with it. I mean, again, this is probably a phrase that a lot of people, if they're interested in development that have joined this webinar, will be familiar with. The saying in test-driven development, all code is guilty until proven innocent. With the mirror test, what you're saying is all code is innocent and the tests prove it. So you're immediately taking a very different approach to that. And it's definitely not going to turn out well, much like if humans just go on gut feel. Human oversight matters, right? So agents don't know what they haven't been told. Sounds really simple and obvious, but if you're asking agents to generate test for your code based on the code, you're hamstringing them. They don't know the business intent. They see the implementation of the code. They can see some metadata. They don't know what that code's protecting. They don't know what risk it's mitigating. Business intent typically lives outside of the code. It lives in tickets, documents, conversations. Be surprised if anybody is encoding internal policies in logic. Acceptable usage boundaries. So I would have thought that's probably not there. You might infer from it, but yeah, what operating constraints your business has to deal with, how things get approved internally. Unless you tell the agent, again, it's not going to be able to figure that out from the code. Agents, so regulation as well. There's no way agents can infer legal obligations from Apex or from metadata. And that can be especially dangerous when you're talking about things like data access, when you're verifying data retention. They just won't know. It's all vital for a robust test suite, but if you just say, here's a method, create some tests, it's flying blind. A couple of other things that agents struggle with a bit is negative testing is hard for them. If you think of when you ask an agent, what should give me some ideas for, I don't know, let's say I was doing this, I said give me some ideas for a presentation about testing with agents. What they're not going to do is say, well, here's all the things you shouldn't mention, don't bring this up, they're always very positive. It's always like, here's 5 bullet points. They're never saying avoid this. And that's the thing, they don't tend to they're optimized to generate, to basically be predicting what's going to happen next, not what shouldn't happen next. So they tend to favor what normally happens over what must never happen. So, for example, if you're not defensively checking for a null value, and your expectation is that nulls may come in and we'll throw an exception and that will be handled in some other way, an agent is unlikely to see that lack of checking as a guardrail. It's unlikely to see it, oh, well, they haven't checked that, therefore that's going to be handled anywhere else. And it's unlikely to give you a test that asserts that the method fails if that is null, because you're not checking for it, you're not looking for it. So they're not great at that. And again, high coverage still doesn't equal confidence, even if AI agents wrote it. They can hit 100% really easily. But again, we don't know what those tests are proving. We don't know what they're testing. So where it all really comes together is humans and agents. So humans design tests just like humans should when they're writing the test themselves. With careful consideration, using proven techniques, we get a much better outcome. So we humans understand why the behavior exists and the purpose of a method. We know what outcomes the business actually cares about, what's important and what's not important. Agents can't know that. So this defines what the test is protecting, what aspect of the business the code is supporting. We need to make sure that's okay. We're good at recognizing we're good at risks because we know where failure is going to hurt the most. You can't just look at code and say, oh, this bit of the code looks more dangerous than this bit of the code to the business. There might be different requirements. It might be reputational issues around compliance, financial loss, or maybe just allowing some poor data through will cause all sorts of havoc further down. But an agent isn't going to know which one of those are important. And it also won't know the boundaries, the thresholds, legal versus illegal states. It won't know that unless we've actually got explicit code in that is checking and saying this. So that's what we're really good at. And what agents are really good at is implementing tests. They're much better than us at this. They don't get bored. They don't get tired. They're terminators, effectively. They never give up. basically, agents are really good at setup. They can produce large, consistent amounts of test data. They follow patterns and utilize factories very precisely. They can keep track of what they've done and what they haven't done much better than us at that. Variations is another area. So if we're doing, something around data shapes, so we need multiple objects, we need some with relationships, some without, different sizes of related lists, some fields populated, some fields missing. When we're doing that, we tend to either shortcut it and just say, oh, this one will do all three of them. That's fine. We'll just put that in. Or we lose track. We end up with 4 tests that are actually testing the same thing because there's so many of them and it all gets so complicated. Or we get confused. We're like, what am I trying to do with this? Whereas agents, they'll just mechanically keep going and generate as many shapes as we're prepared to wait for and as we're prepared to pay for. And they are good at writing boilerplate code, repetitive Apex code. They're much better than we are. They don't think, oh no, I've got to write another test where I've got to do some setup and I've got to do some search. They're much better at that. So they can remove a lot of, what I think is the friction of writing tests is that there are, some mechanics around it. But they'll do that respecting the human supplied design. So I guess the kind of my key point is humans decide what to test. Agents decide how to test. And to go back to my 0 to 30% discount again, rather than saying test me this method, I would be saying give me some tests for a method, not necessarily this method, but a method which verifies that a discount is between 0 and 30% and it includes 0 and 30. And I want you to test the lower and the upper boundaries to make sure it transitions okay. If you do that, you'll get a nice set of tests. And you've done the design. And if you've got deep pockets, rather than having to prioritize, an agent will be able to build you all of the tests that you require very, very quickly, as long as you're able to pay for it. So I think this is where we're going to be best, is where we're working in conjunction. We're not delegating everything to the agents. We're not handing off testing. We don't care about it. We're giving them all the context, all the information. We're giving them the decisions, and they then decide how they're going to write some code to implement those tests that we've required.
Okay.
And that's basically what I've got to say.
Yeah, no, I think love the points here, Keir. Somebody on our chat has asked, what's one testing decision you wouldn't let an AI agent make autonomously today, and what would it need to prove, like evidence, metrics, guardrails for you to trust it?
That is a great question. I think the testing decisions I wouldn't let AI agents make in general are around things that can be changed by humans without them realizing it. So I think things around access to data driven by permission sets, profiles, that kind of thing, I think I'd be very reluctant to allow agents to make those decisions, simply because there's a whole compliance thing. So I think that'd be hard to defend in an audit that I'd delegated that to AI anyway. I think I'd definitely need to be making that decision by myself. And also I think they're so changeable by human admins. I also don't think I'd probably unit test that, to be honest. I think I'd probably do that a different way. What would it need to prove? Again, I think it wouldn't be about proving to me. I know this is like a really, really rubbish answer, but it wouldn't be proving it to me. It'd be, what would I have to prove to an auditor, to an ISO or a Cyber Essentials auditor who's saying, so, how did you decide that these tests were appropriate? Because it wouldn't matter if I thought, I was satisfied with the guardrails. If that wasn't something they were satisfied with, it would end badly for me. But I think things around security, etc., it's probably still quite early days. And we've still got to check their tests, right? They're really good at writing them, but there's, they may hallucinate. So we've still got to keep track of that as well. I think the better guidance you give it and the better design you give it, the less hallucinations you're going to get. But they're still, I think I'd be a way off trusting everything, to be honest.
Yeah, I think that's a
Great
very
question.
sharp answer. Yeah, and
Great question.
that also uncovers this hesitation, that this is what we should not give over, and there is still the human's neck on the chopping block. God forbid in that audit if something goes wrong, nobody's gonna go and blame Agentforce vibes. It is Robin who was using it while deploying it.
Yeah, absolutely.
Yeah,
Absolutely.
interesting. Okay, also, we had one question which says with agents, we can test the tools, their process, etc., but the decision making, such as responses, the tough part. As the line between both blurs, is there a case for approaches used for humans, an interview process and supervised probation, for instance, for the agent?
Oh, hang on a minute. Let me just, with agents there, we can test the tools, their process, decision making is the tough part. It's line between both is a case for approaches used for interview process and supervise. To be honest, I would have it totally. I would have it on probation going forward. I wouldn't be trusting an AI to do anything and just pushing. I know the what was it, the Malt bot or the Claude bot or whatever it was called.
Yeah.
He was saying he pushes things into production, and if it breaks, he goes and fixes it, which I think is a very
Yeah.
courageous way to do it. Yeah, I wouldn't be at no point in my career could I have done that, because I would effectively have been taking an unacceptable risk with customers or with my own organization's production system. So I think, I think until they can do things like, unsupervised medical procedures or military operations, I think
Yeah.
we'd be foolish to show that level of trust to them. I think I'd need to be a lot more convinced. But I think the interview process is very much, try it out, see if it's any good. So if it's not working and you feel you've given it the best design you can, then that probably is time to look for another one. But I would keep it permanently on probation. It'd be like being, out on license. If you're a lifer, you're never off the hook.
Yeah, I love that. Okay, there is also one more comment. Human is at the testing helm, HITL. So I think that is very important that, the time has come. Yeah.
Yeah, absolutely. I think that's a really good way of putting it. We're still in charge, but they're a really good, helpful, and willing assistant. We just have to remember they're quite junior as well, and they're a bit prone to making mistakes, so we shouldn't have too much trust in them. But they're also, like junior human assistants, they're getting better. They're getting better all the
Yeah.
time. So, who knows? In a few years, they might get to the point where we can trust them. I'm not there yet, certainly.
No, I love it when you said that trust is the main thing. Also, like when I was a junior developer, I was trying to make my boss very happy. I see that
Yeah.
same tendency in the AI agents. Like they're
Yeah. Oh,
trying to make
yeah.
the boss like very happy. I don't know, promotion or whatever.
I rarely ask ChatGPT a question and it doesn't say that's a great question.
That. Yeah, exactly. Yeah, I think so. I read this paper about the psychophantic nature of LLMs
Yeah,
because of the way in which they were trained. RLHF, they always optimize for the human feedback. Like, it's a great
absolutely.
question. Sorry, it's my mistake. Let me redo that. It's okay. ChatGPT, don't
Absolutely.
worry.
That's right. Don't take it so hard. I forgive
Yeah,
you.
it's okay. Yeah, don't worry. Yeah, interesting. Okay. I think those were some of the questions we have. We do have some
Okay.
slides at the end, Care, with a nice
Yep.
surprise for the audience.
Yeah, cool. So if you liked what I said about testing today, have a look at the link on the left-hand side, testing book. So I'm writing a book on Apex testing, but I'm writing it in an interesting way where it's kind of published before it's finished, hopefully at a reasonable price. So please read the blog post first, don't just rush off and buy it and be surprised by some of the terms that are there. And also, if you've enjoyed the sound of my voice, then I'll be doing a Spring 26 webinar next week where I'll talk about I don't actually talk about testing in that because it's aimed more at a business audience, but there is new run relevant tests functionality in Spring 26. Definitely have a look at that.
Yeah, I
And I
think
think it's
two parts. Can you maybe Radhika on the back end side can help us with the link in the chat, and then Care can like people just like buy the book right away.
yes, they can buy it right away. The key thing is the book's not finished, and the risk you're taking is I may not finish it. So it's priced quite competitively, I think, reflecting that. I do plan to finish it, but in an infinite universe, we never know what's going to happen next.
Interesting. Also, you mentioned about this new Spring 26 feature
Yeah.
about relevant tests. Can you briefly touch on
Yeah,
that?
sure. So run relevant tests is where you're saying effectively it's you're handing over control again. You say to Salesforce, you pick the tests that you think are important. However, you don't just have to leave it to Salesforce. So you can also give it some there's some new attributes on the is test decorator annotation. So you can basically say, if this class changes, you need to run all of these tests in order to confirm that it's working as expected. All these things depend on it. So you can give it some clues as well. So I think that's actually really good. I think you've got a level of control. And there's also an is critical attribute, which basically says, I don't care what's changed. I don't care if no Apex code changed. Every time you deploy to production, you run these tests. And I really like that.
Very interesting. And these are still to your, theme that you are following in this session. These are still decided by humans, not agents yet.
Absolutely.
Yeah,
Absolutely.
interesting. Yeah, got it. Okay.
Do you want the next slide?
Yeah, please. Awesome. Thank you so much. So I'll just sum it up. First of all, from the bottom of my heart, very happy that we have Keir and we had such nice insights of the 5 episodes and chapters we've done for this webinar. I'm very confident that this is one of those like very energy dense and information dense ones. People who watch this like even 5 years later would be thankful that we did this one with Keir. That being said, we are Team TestZeus. Thank you. This is the QR code which will lead us to our website. We are also hiring. So come join us if you're on a mission. You can also join us by just trying out the product, giving us feedback, and to Keir's point earlier, improving the quality of a product. That's about it for today. We are at the 46-minute mark. Thank you once again, Keir, for the insights and
My
loved
pleasure.
having all of
Thank you for
us.
having me.
Thank you.
It's been great. Bye, everyone.
Yeah. Bye, folks.